Hello guys, welcome to day 6 of CS1. Now originally Ethan taught this class in the Discord server, but we ran into some recording issues, therefore we couldn't really capture the entire session. So I, Haiyan, will be basically making up this lecture, and hopefully this will be helpful for those of you who didn't really get to join the class. So yeah, let's just get started. So day 6, we went over essentially graphics. So over this class, we're going to go over downloading and running the CMU graphics library, creating shapes and text, custom colors, as well as dynamic sizing. So for the first step, we need to set up the CMU graphics library. And in order to do so, please download the Python library given this link. And yeah, all these, this slide specifically will be posted in the resources channel, so please be sure to check that out. And yeah, so please download the Python library at this link, just copy and paste it into your browser. And then next, you're gonna open in Replit, and then you're just gonna navigate to this three-dot icon. You're gonna choose upload file, and then you're just gonna select the downloaded Python library. And I just have a screenshot of it over here. Again, you're gonna click this three-dot icon, and you're just gonna choose upload file, and you should be prompted with the file explorer of your OS, and you're just gonna choose the Python library, and it should be uploaded into your Replit, and everything should be good to go. Now, in order to test if it works, we're just gonna create a blank canvas. So, basically in your file structure, you should have two files. One called main.py, and you should also have the CMU graphics library. And so yeah, in total you should have two files. And in your main.py file, just copy and paste this code, and this will check and see if the library does indeed work. And yeah, you can see here that we use this library called CMU112 graphics. Coincidentally, it's also named the file. And we're just going to import it, and we're basically going to use its functions, its classes, which will allow us to make these shapes, text, whatnot, basically. So yeah, now if this works, that means your Python library has been imported properly. If not, please do ping one of the team members, and we'll get you all set up. So yeah. So basically, let's create our very first shape, a line. Now, let's just copy this code and paste it into our program. Be sure to stop the program and then rerun it so that the updated code will display onto the output. And you can see here that we have indeed made our very first line. And I'll go over its detail right now. So basically, we're going to use this function called createLine and input basically 2 points, its start and its ending. And after that, we're gonna basically create an instance of this sort of shape object. So we're just gonna say, okay, I want to run an app, and I want to make its dimensions 400 I believe pixels by 200. And then this is going to basically run this code within this function, and this is going to say, okay, so this canvas that we have created of with the dimensions of 400 by 200, we're gonna create a line within this canvas, and then we want to make a point that starts at 2550. So this will be X and this will be Y, and then we want to make the line end at whatever the width of the canvas basically is. So basically 400 divided by 2, which is 200. And we also want to make the y coordinate 200 divided by 2, which is 100. And you can see here that basically this point is essentially the center of the canvas, right? If you think about it. For example, let's just say we have this point, right? Let's just say a point of 400, 200 exists, right? And if we take half of those, we will now get the center of the canvas. And you can see here that this is actually accurately displayed on the canvas, right? we see this ending point, which is located right, smack down right at the center. And then we're gonna have a starting point at 2550 essentially. And yeah, that's basically how we're gonna utilize this Python library, right? We're basically going to create instances, right? Objects, right? And then we're gonna say, okay, we want to create this object, right? This canvas essentially with whatever attributes we want to assign to it, right? So basically we're gonna assign like its dimensions, and we're just gonna use its embedded functions, right? To create shapes, lines, text. And that's basically how we're gonna proceed from now on. So yeah, hopefully that was helpful, and let's mention one more thing. So one of the main things that you should probably note is that the y-axis actually grows downward instead of upward. And this means that basically as the y coordinate increases, it actually is located downward essentially, right? And this kind of makes sense because whenever like you resize your, for example, a window, right, the top part always seems to remain intact. Therefore, this means that 0, 0 would be located at the top left, right? So the x, basically the mechanism for the x coordinate remains the same, but it's just the y coordinate that is sort of different, right? And this may take some time to getting adjusted to, but yeah, that's one major thing to note. So let's, for example, in our code, let's just say we want to increase y, right? So let's just say 100, right? Now notice how the point is located right here, right? And let's just rerun it. And you can see here, right? Now the beginning point has shifted downward, right? And yeah, that's sort of something that you should probably note. Okay, let's look at the next shape, rectangle. Okay, so everyone please copy this code as well. Rerun your program. And you will see that there's a rectangle. Now, obviously this is a square since the x length is 150, since the x2 minus x1 is equal to 150, and as well as the y length, which is y2 minus y1, which is also 150. So we can also, make this a rectangle. Let's just say we want a length of 200 and a height of 150, and you can see here that this creates a rectangle. Now you may not see like the outside border of the top and the left side, and that's just because it's directly at the edge of the canvas, therefore it might not be displayed properly. So we could always shift it, maybe by 5 pixels or whatever units the program uses, and you can see now that it's more obvious that it is a rectangle. So yeah. I'll also mention again that this takes in basically the top left of whatever this point is, and it will basically create a rectangle or a square based on from the starting point of top left to its lower right point. So you can see here that this starts at 5, 5 over here, and then we're just going to essentially drag it or kind of like enlarging it until it stops at 200, 150 over here. And yeah. Okay, let's do a progress check, everyone. I want you guys to create a tic-tac board with essentially 9, preferably even boxes, but if not, that's totally fine. Yeah, everyone please try your best. And I'll give you guys this moment to pause this video, and hopefully you can work out the solution, and I'll go over the solution in a second. Okay, now let's go over the solution. So basically we want to create a tic-tac box, right? And we also want to create basically 9 inner boxes, right? Smaller inner boxes. And one of the, I guess, faster ways you can make this is if you notice that, okay, we technically just need 5 objects, right? We need an outer box, we need just 4 inner lines total, 2 going in the X direction and 2 going in the Y direction. And that's one way you can approach this. You can also create 9 individual boxes, and yeah, that's essentially it. So I'll just go over the solution. So I'm just going to import the library, graphics, import, and we're going to call, first of all, create, and we're going to call this later on. And basically, we're just going to create, any square, right? I'm just going to create a square of length 100 by 100. I'm just going to also shift this toward the canvas, the inner part of the canvas, so that we can actually see the top and left side of the square. And let's just first, don't forget to use this line of code so that your program will actually work. This should be good. Okay, there we go. So now you can see that, now you can see here that we made a square, and let's just create the 4 inner lines essentially. So basically, here, let me just copy this so I don't have to repeat myself. And okay, so wait, my bad, I meant to write this. Here, let me just comment these as well. Okay, I'll go over each line one by one. Okay, so basically my approach to this is basically taking this starting point as well as this ending point, and we're just gonna divide this length essentially, which is 100, by 3. So then if you notice, 100 divided by 3 will equal around 33.33, but we're just gonna round it down to 33. And I'm just going to add 33 to the X coordinates, right? Because think about it, the Y direction will remain unchanged, correct? So we're just going to change the X direction here so that it will be shifted a third of the way, a third of the box length essentially. So that's what I did here. I just added 33 to these 2 X coordinates, and this will basically create this specific line. And that's basically the approach I'm taking, right? Utilizing the third rule and basically adding that to the X direction as well as the Y direction of the length and height of the box. And that's essentially my solution, and I'll just write the rest of the code, and hopefully you can understand what I'm doing. Just give me a second to write this all out. Please let us know if you have any questions. And that should be almost it. And let's see if this code works. So yeah, there we go. A Tic Tac box. Yeah, that's pretty much the answer to the progress check. Okay, next, graphic parameters. So essentially, right, we created boxes, right? We created lines, but they lack essentially some character, if you will, right? Here, I don't know why this code isn't working. Give me a second. Okay, there we go. Or not. Give me a second, guys. Okay, wait. I think I got the problem down. Okay, let's see if this works. Okay, sweet. So basically, previously we were just working with essentially black and white shapes, right? And that's totally fine, right? But what if we wanted to add style to it, right? What if we wanted to add, a different border color, right? Maybe a fill color. What if we wanted to sort of broaden the border, right? To make it more thicker, right? And basically these parameters, right? These arguments, if you will basically allow us to give this give these shapes and lines more like character essentially. So basically what I'm doing here is I'm just here, let me just show you first of all what it would look like without any styling, right? So this will be your white and black generic box, right? And that's totally fine, right? But if we wanted to basically spice it up and create one with more flavor, we can always utilize these arguments. So let me just go over each argument. So this fill argument will basically, define your fill color, right? So for example, we specify yellow, therefore our fill color over here will be yellow, right? We can also specify the color of our border, right? And if we wanted to make it red, we can specify that, and indeed it will be red. We can also specify, like the width of the border, right? And we define it as 3, and therefore our border will be a little bit thicker, right? And we can always modify these values, if we wanted something different, right? Maybe I wanted a blue fill, and let's say I wanted a green outline, right? And maybe I wanted to make this more thicker, let's just say 100. I'm just going to shift this to the center of the canvas so that we can see the edges. Outline, okay, yeah, it's because I made the width too big. Let's just make it 3 again, I guess. Yeah, okay, there you can see the blue now. The previous problem was the width was so big that the border actually like overlapped the inner blue section. So yeah, if I wanted to make the border more beefy, let's go with 10. That should be safe. Right now you can see it's much more beefier essentially. So yeah, that's pretty much it for that part. We can also go over additional shapes, and yeah, please copy this code. Let me just close this sidebar so that you guys can see the comments well. Okay, that should be good to go. Okay, yeah. So let's just go over each line of code one by one so that you can understand it better. So there is a create oval function within our CMU graphics library. And basically, we're going to define its bounding box, right? Instead of actually, inputting 4 different points, for example, its vertices essentially. We can just specify 2 points, basically its bounding box, just like how we did for the rectangle, right? We're gonna define the like top left point and then basically drag it down to its bottom right point. And this will basically create our oval with a much simpler method. And yeah, that's essentially what I did here. I just created inputted a graphics parameter for the fill, made it yellow, and hence my oval is yellow. So that's pretty cool. We can also make a polygon. And yeah, essentially we need at least 3 points to basically define our polygon and map it onto the output. So for example, we can see here that we have 1, 2, 3, 4 points in this one, and we're just going to define its fill color green, and that's pretty much it. We can make it have a outline, yeah, outline of, let's just say red, right? Yeah, we can have an outline of red. We can maybe shift it, let's just do 150. So yeah, so basically the first point corresponds to this left point, and I believe the second point will correspond to, let's actually just check it out. Okay, so the second point corresponds to this bottom one. The third point will probably correspond to Yeah, the right one, and then the fourth point will correspond to the top one. And that's pretty much it for polygons. Obviously, we know we already went over lines, but just in case, let's just go over it. So yeah, we can define the width, the fill of it, and make it more interesting. And probably everyone's favorite, we can create text, right? So basically, we're gonna define its center essentially, right? So we can also shift this center to the right, and you can see here that it's shifted a little bit to the right. And then we're gonna define our text. Amazing. We're gonna fill it with a certain color, and we're just gonna define its font, right? So I'm not sure what like the list of fonts that are available in this library. You can probably look over the source code to double check it yourself, but let's just change it up to a generic one like Arial. Let's just make this a little bit smaller, like 15. Maybe we don't want it to be bolded. Let's see if this works. Yeah, so you can see here it updated accordingly, and that's pretty much it for additional shapes. And yeah, so we can also add colors. Okay, okay, whoops, sorry. Always make sure to indent your code so that it's within its proper scope. Okay, sweet. So basically, we have this function that we're gonna call within our redraw all function as well. And this will allow us to basically input hex values for our colors. Because the main reason why we can't just directly input the hex here is because whenever we use a hashtag, you will notice it's going to be rendered as a comment. Therefore, if we use the f string, we can actually input the hashtag, and you're going to notice that it's not going to be green like a usual comment. And that's what we're basically doing over here, right? We're going to basically take these values, these three values, and we're just going to output just like the following. So for example, this will be whenever we call this RGB string value, we're going to output it exactly like this, including this hash 147.197.114, I believe. Yeah, that sounds about right. RGB. Actually, let's just print out this to make sure that is correct. Or not, actually. Print pistachio. Okay, whoops. Okay, yeah, you can see here that, okay, so it's basically going to take this decimal and convert it to its corresponding hex value. So 147 is in its decimal form right now, which is what we humans use. But another basically encoding that computers use is called a hex, right? There's also binary, which you might be familiar with, which is just ones and zero. And hex is just it's short for hexadecimal, and it's just a way to basically represent a number in another format, right? So 147 is going to be equivalent to 93, right? So 93, so basically each of these decimals will correspond to two characters within each of these values. So 147 will be equivalent to 93 in hexadecimals essentially. And that is this specific part I'm highlighting. Let me just make this bigger. This specific part I'm highlighting will be the thing that will be outputted by this function essentially. And yeah, that's pretty much it. So yeah, let's see if this code works. Okay, there we go. I'm just gonna revert this back to its normal code, and that should be almost there. Okay, this should be it. Okay, there we go. So yeah, back to what I was line block of code essentially. So we're just going to define two different colors, pistachio, which is this top left block, and maroon, which is this bottom right part. And we're just going to say, okay, I want to create two rectangles, one located at this top left and one located at this top right with different colors. And yeah, that's pretty much it. And yeah, whenever you want to use whenever you want to find like the corresponding hex code for a specific color, feel free to check out this linked resource. It's called Color Hunt, and essentially it's just going to offer you a lot of different color palettes to choose from. If there's a specific one in mind, you can just hover over it and you can see its corresponding hex value. So yeah, like so. And yeah, you can essentially use that in your code. What I would do is I would first of all copy it, and I'm just going to search online basically this hex to RGB color converter. And I'm just going to input my hex color code, convert it, and this will give you your specific RGB values, right? And basically R stands for red, green, G stands for green, B stands for blue. And what you're going to do is you're just going to paste each of those individual values into each of these arguments. And if we run it, it should return, yeah, there we go. We got the exact same color as the color we chose. And yeah, that's basically how you utilize the Color Hunt resource. And hopefully this will let you customize your shapes to what you want it to be. So let's talk about centered shapes. Let me just close out of these. And let's just run it. Okay, let's just look at this one approach at a time. Give me a second. Okay, let's run this. You know what? Let's just keep both of these shapes and see if that works. Okay, so let's just look at this one shape at a time. So the first shape I want you to look at is the dark green one. And basically what we're going to say is that we're just going to define a margin, and we're going to use that for the starting and end points. So for example, we're going to have a margin of, let's say, 10 units, right? So we're going to start at basically 1010, which is over here. And if you think about it, right, if we start at 1010, that means that its margin will be indeed a length of 10. And this is exactly what we want for centered shapes, right? And we're also going to start at 1010, and then we're going to end at basically this entire width, this entire height, and we're going to subtract 10 from that. And this will also yield us this end point over here. And you will notice that this dark green shape looks exactly in the middle. And that is basically the vision that we're going for. Okay, and that's basically the first approach you can do, right? Defining a margin and setting that to essentially your starting and end point, and just adjusting, just coming up with expressions basically to match your needs. The second approach, let me just format this so it's easier to read. Okay, the second approach is basically, let's see, basically coming up with 4 different values, basically 2 values. So first of all, we're going to find the exact center, right? And this will yield us the exact center, since we're going to divide this app width by 2, and we're going to divide the height by 2, which will give us this specific point. And we're also going to say we want to specify or come up with the width and height of our rectangle, which is going to be app width divided by 4. So that might be, for example, here. And then we're also going to get the height divided by 4. So it will be around here. Okay. And yeah, that will basically give us this point here. And then we're also going to divide. Yeah, okay. And then we're just going to say we're going to create a rectangle. And then we're just going to basically come up with expressions that will yield us this value. So for example, cx minus the width divided by 2. So in total, basically this will be the app width divided by 8. Since rectangle width is going to be app width divided by 4, and we're just going to divide by 2 again. So that's going to be app width divided by 8 in total. So that means that this point is basically the center minus an eighth of this width, which will yield us this starting point. And then that's basically how the mechanism works for the rest of these values. Yeah. So yeah, for example, we're going to stop at the x coordinates of this value, and you will notice here that instead of subtracting it like here, which will yield us basically this negative value, since we start at the center, cx, and we're just going to subtract a value from it, right? And that will yield us a point in the left direction. And instead of doing that, we're going to add it, which will give us a point in the positive x direction, which is, it makes sense. So yeah, that's basically how this second approach works. Okay, and now let's look at helper functions. Okay, great. Give me a second, guys. Replit is really a bum for being sensitive about its spacing. This should work. Okay, there we go. So basically what a helper function is, it's essentially an external function that will help us within another function basically. So for example, in this redraw all function, we're gonna call this helper function multiple times so that it will prevent us from writing the same code over and over again, right? Instead of having this whole chunk of block repeated a total of 26 times, I believe, since we're going to repeat this outer loop 4 times, inner loop 6 times, therefore this whole thing will be 24 times, and as well as calling these 2 additional ones, so a total of 26 times. We're going to basically create a function that will basically allow us to use this code, but at the same time prevent us from having so many lines of code. And that's what basically a helper function does, right? So yeah, so let's just go over this. So for example, this draw Belgian flag will do exactly like its name suggests. It will create a Belgian flag given its starting point at the top left, as well as its ending point at the top right. Bottom right, excuse me. And yeah, it will create its black, yellow, red parts, which will constitute its Belgian whole, essentially. So yeah, and we're basically going to call those, call this helper function throughout our redraw all function, which will allow us to basically utilize this repeatability functionality, essentially. And yeah, that's what we're going to do. You can see here that this will create this Belgian flag, this bigger one. This line of code will create the medium size Belgian flag, and we're just going to basically utilize this helper function and create a lot of smaller versions of it, and we're just going to make an array basically. And we can see here that the margin is 5 units, meaning that the spaces between all of these Belgian flags, these mini Belgian flags, will be 5 units. And you can see here that we're going to basically create 4 columns here. So you can see that there's 4 columns, and we're going to create we're going to create 4 rows, hence the 4 rows here. And then we're going to create 6 columns, hence the 6 columns here, excuse me. And then basically we're going to say, okay, we want to start at like the left top. Okay, let me see. Let's just modify this and see what happens. okay, so this will be basically its x coordinate and this will be its y coordinate. And we're going to say, okay, we want to start at 250, and then we're going to modify it along the way based on, you know, like how far we are into its iteration, and taking into account basically the margin as well. And that will basically map out this array of Belgian flag for us. And yeah. Okay, let's look into dynamic sizing. Okay, indenture code, and that should, okay, I don't know why this isn't the same line. Okay, that should work. Okay, let's take this, yeah, let me just comment this out. Okay, so basically, we're just gonna use the approach number 1 from this slide, right? Which means that we're gonna define a margin and we're just going to create a starting and ending point based on its margin, as well as the app width and height. So that's basically what we're doing. And we're also going to basically create a text at the center of the canvas right here, and it's gonna say hello world, and then we're gonna name its font, right? We're gonna use Arial, we're gonna bold it, and then we're gonna specify its text size in this basically expression between these curly braces, and this text size is going to be executed and basically rendered, and then that value afterwards will be basically replaced here. So this is essentially the same as, you know, like whatever value this returns, and in our case it's going to return 400 integer division, I think. Yeah, integer division, and then this is going to yield us 200, and then we're basically going to replace 200 in for this expression, which is going to be basically this, right? And if I run this as well, you're going to see here that, okay, wait. Oh, wait, sorry, I meant 20. I cannot math today, so excuse me about that. And this should, yeah, so this should basically output the same results. Yeah, so the reason why we want to have this external variable basically is because our dimensions of the canvas will change, right? We're not going to keep it 400, 200, right? This might change based on your needs. Therefore, we want to basically have this sort of variable that takes into account the width of the canvas, right? You know, whichever dimensions we use, and it's going to dynamically size, dynamically place our whatever we want, right? Shapes, lines, based on what width, height we choose, right? So for example, we could change the width to be 800, and this is basically going to enlarge our canvas in the x coordinate, and you will notice that the text will be still placed in the center. You cannot, yeah, okay, there we go. So yeah, if the whole thing is displayed here, you will see here that the text will still be placed in the center, right? Despite us changing the width of the canvas, right? And this is basically called dynamic sizing, meaning that no matter what attributes, no matter what values we input for creating the canvas or anything else, whatever code we write, that dynamic code will basically readjust itself to fit our needs. And that's basically the cool part about this. So yeah, like I said, again, this text size variable will be rendered separately, right? It's not going to be rendered as a string just yet. It's going to take the output of whatever this is, basically place the value in for that over here, and it will output that as a string then, right? And that's going to make it yield as a like this result over here. And yeah, that's pretty much it. So let's have a progress check. We're basically going to draw the French flag, or basically any flag if you want, and you're just going to write your name in the center of it and post a picture in the class chat if you're done. And yeah, I'll give you guys some time to pause. this video, and hopefully you guys can write the code for it. Okay, welcome back to the video. I'm just gonna pull up the solution. Give me a second. Okay, there we go. I'm just gonna replace this with my name, and this should output the French flag with my name. Okay, there we go. So basically what I'm going to do is I'm going to utilize the method 1 from before, where I'm going to create a margin, and we're going to basically evaluate our starting and end point based on its margin as well as the width and height. And then we're just going to create a centered rectangle like this over here, as well as making 2 additional rectangles, the blue and the red one. And we're going to utilize the third rule, from before again. So for example, you might notice that, for example, if we wanted to make this blue rectangle here, the starting point will be the same as this big white rectangle we have in the background. Yeah, so you might notice that the starting point will be the same, but we just changed this endpoint, right? The x coordinate of this endpoint to be a third of whatever length this white rectangle is. So you will notice here that we're just going to divide this width minus margin, basically this point, and then we're just going to divide by 3, and that will yield us this endpoint here. And that's what we did for the blue rectangle. And we're also going to do the same for the red one, except we're going to shift its start point to a 2/3 of the way across this length. So we're going to multiply this by 2, and we're going to divide by 3, and that will yield us this red rectangle. And that's pretty much it. Obviously, this implements our dynamic sizing code from before, so that no matter what our width is, you know, if we wanted to make it 200, right, it will change accordingly. And yeah, there you go. So yeah, that's pretty much it for the progress check. Hopefully that was helpful. Okay, so now, yeah, that's pretty much the end of the class. Here is the homework for today's lecture. You're not going to submit it in Codeforces or something. You're actually going to submit it in the Day 6 Homework Showcase channel. And basically, you're going to create any kind of pizza, essentially, right? You can create pineapple pizza, Hawaiian pizza, meat lovers pizza, anything you want. And basically, I want you to utilize everything we've discussed today, you know, circles, you know, styling our shapes, like giving it color, giving it more width. And I want you to create a tasty looking pizza that will make me hungry. And that's pretty much it for today's class. Everyone, thank you for joining, and I hope you got something valuable out of this. Okay, I'll see you guys.